intelligent is based on the computations, based on a lot of computations. If many computations are there, uh, intensive computation are there, iterative computation is there, then whatever the intelligence is obtained for that particular system is the computational intelligence. What I want to say that, we are the natural intelligence. The human beings are born intelligent, right? Because we have the features, inbuilt features that we learn from the experience. Or the living beings are intelligent. Actually, not only the human beings, the birds, anybody are the by default intelligent, right? They know how to survive in the environment. But what about the non-living things? Is it possible that we can make the non-living things like birds? Can we make a swarm of machines which can fly like birds? Can we make a swarm of robots which can behave like a crowd of humans? Is it possible? Can we make some, some water robots for the water, underwater robots, which can swim like fish and can solve our problem, can search the unknown areas of the sea autonomously without any guidance. Go and search. This is your target. Do it. Accomplish the task this way. Is it possible? Yes, it is possible actually. Now, having this much computational efficiency, it is possible to make the non-living things intelligent better than the previous time, which are which are intelligent close to the living beings, close to the living beings. Of course, not exactly the living beings, because living beings are the creation of the God, ऊपर वाले की बनाई हुई चीज हैं. So we cannot equate ourselves with the God, but yes, we are making the devices quite close to the human being, close to the birds, fish, or the bees, or the monkeys. We are making these devices very close to those. You may have seen on the link. I can share the link after this lecture. There is a YouTube. Yesterday, there was a program of Indian Air Force, and it was shown that the drones are flying together. Drones are flying together like birds. They are going in a particular area. They are searching the target. They are dropping bombs. They are coming back. Everything is autonomous. Just one press of button, that takeoff button, mission start button is there, and then everything is done by itself, by the drones itself. Just imagine, means we have prepared a system of drones which is accomplishing task by itself, autonomous system. And this is possible. Yes, it is possible with the help of computational intelligence based algorithms. So what are these algorithms? So in general, let me tell you, any study where we design the intelligent agents is the computational intelligence. I tell you that agents may be anything. It may be drones, it may be robots, it may be my pen, it may be a laptop. My laptop understands the brightness of the room automatically, and it adjusts the brightness automatically. These days, every laptop, mobiles have the intelligent system like this. All this is intelligent. All this is intelligence. When I bought my mobile, and my name is Jagdish. No, my name is Jagdish. When I was typing Jagdish, J-A, I started typing J-A. It was not predicting Jagdish. But after use of 1 week or 2 weeks, it started predicting Jagdish. Try to understand. Lot of time I have inserted, I have I completed this word Jagdish after typing JA, right? So it understood that lot of data it has taken, and now it understood that this man, whenever type JA, most of the time he finishes with the word Jagdish. So it started predicting Jagdish. It's an intelligence. When the manufacturer company made this, it was not inserted that whenever JA, you predict Jagdish. If you are the owner of this, it may predict something else. Means based on the input, the system is learning itself. Based on the environment, the system of drone is learning itself that where is the target and what to do, what the decision is to be taken. So these kind of autonomous systems are to be designed in the computational intelligence based algorithm. I hope no need to say that how much important this computational intelligence these days. No matter in which area of application you are working, whether you are in biomedical, you are in agriculture, you are in mechanical, civil, energy related problems, electrical engineering related problems, computer science, mathematics, science, economics related problem, finances related problem, whatever area you are there, you need some intelligent system. Everywhere you are requiring some intelligent system which can work in autonomous way, where the external input can be minimized as much as minimized. So, and this is possible based on these kind of intelligent algorithms which are derived from a lot of computation, and that's why we call them the computational intelligence algorithm, computationally intelligent algorithm. They are the intelligent algorithm. The system is intelligent because of lot of computation, right? So computationally intelligent, they are computationally intelligent, they are not mathematical intelligence. Means whatever the intelligence is obtained in those algorithms cannot be verified mathematically. We cannot derive the formula mathematically. All these are based on the iterative computation. Okay, so now what to do to make any agent intelligent agent? What we are doing in these algorithms, let me tell you. You have any agent. Suppose you have an agent and you want to make this intelligent. So what are the properties? What are the properties which are to be inserted? Property 1, property 2, property 3. First of all, we need to identify that what is the problem. According to that problem, what kind of properties are required to make this agent intelligent agent. And first, after identifying those properties, these properties are to be inserted to this agent. Means this agent is to be trained. You know, for example, I am trained in swarm intelligence. I'm not trained in electrical engineering, right? You may be trained in electrical engineering, you may be trained in civil engineering, you may not be trained in swarm intelligence. So I can solve a problem if it is in the area of swarm intelligence. You can solve a problem if it is in the area of electrical engineering. You are trained in electrical engineering, I'm trained in swarm intelligence. Similarly, an agent is trained for a particular kind of problem, and that's why I hope you heard about this narrow AI. So whatever the AI is a narrow AI. Artificial general intelligence is still a concept and is coming up. Hope in next 20-30 years we can have the artificial general intelligence also, but right now we are developing intelligence agents for a specific kind of problems, right? So this the problem as per the requirement of the problem, we will identify the properties and will insert these properties to this agent, so that this agent have these properties. The process of inserting these properties to this agent is an algorithm, and this algorithm is computationally intelligent algorithm, right? So what are the properties which makes any agent intelligent agent? So these are the properties actually. So sometime it hangs with it. Just yeah, now it is okay. Any agent should have whatever it does is appropriate for its circumstances and its goals. Whatever it does is good for its circumstances. You know, the teachers teach. Sorry. The teachers teaches. Truck driver drives the truck. You know, anybody intelligent agent understands that what is good for me. If it is good for me to attend this lecture, I will attend, otherwise will not attend, right? So intelligent agents should understand that what is good for them, the first property. If it is not good for them, don't waste the time, don't waste the energy. Another thing is it is flexible to changing environments and changing goals. If the environment changes, it can change its goal. For example, suppose I'm not into academics. I'm no longer into academics. I started my business. Suppose I started my business for my earnings. then of course I can, I may not attend the lectures on swarm intelligence, even if it is on swarm intelligence or in computational intelligence, on any topic. I will not attend the lecture. I will attend the business meetings, right? So if the environment changes, goal changes. Intelligent agent, it learns from experience. Very important property. It always learns from the experience. That if, for example, my mobile learn that whenever this man types JA, it finishes with Jagdish. The word finishes with Jagdish. So it learns from experience. More the input, better the output, right? So it learns from experience. The fourth property is it makes appropriate choices. Appropriate choices. Actually, what happens if some agent is not intelligent, then it cannot make appropriate choices. It means, for example, suppose there are two choices, X1 and X2. For an agent, there are two choices at any stage, that it can take any value X1 or it can take the value X2. Then which value should be taken? Then this agent should be intelligent enough to understand that this X1 is good for me, so it will adopt the value X1. Means if there are more than one alternatives available, then agents should be able to understand. Agents should be able to understand that which alternative is good for me. This is another property. So if these four properties can have, any agent, any non-living thing, if these four properties can have, then any non-living entity can also become intelligent. And how to insert these properties into a non-living thing? The same way a child learn. Suppose a newborn baby is there, right? Newborn baby is there. So how he learns, how he become. When I took the birth, I was a newborn baby who does not know anything. Forget about swarm intelligence. He does not know that what is hot or what is cold. The difference in hot and cold does not know a baby, but it learns from experience. After that experience, he keeps this in the memory and so on. So whatever this baby does, whatever a newborn baby does, the same thing we can do with an agent. We will consider that this agent is the stupid agent. Let me tell you, stupid means no knowledge. It has no knowledge of the solution. Initially, it has no knowledge of solution, and then it will do the same process which this baby does. And what is that? I'm coming to that. Before that, let me tell you, let me just be frank that this is not the exhaustive list of CI techniques, but broadly, I feel that CIs can be classified into three major classes actually: swarm intelligence based algorithms, evolutionary computation based algorithms, and the artificial neural network based algorithms. So I think you know that this DL, CNN, all these things are there in this category. So I'm not listing those separately. So swarm intelligence based algorithm, evolutionary computation based algorithm, and artificial neural network based algorithms. These are the broad categories of computational intelligence. Okay. Now, if you ask me that where the computational intelligence is, in which area it lies, actually it is the special case of artificial intelligence. I hope there's no need to tell me that what is the artificial intelligence. Any intelligence which is obtained artificially, which is by training, is the artificial intelligence. And when this training is iterative, when this intelligence is obtained, when this artificial training to an agent is based on high intensive computation, then this artificial intelligence is known as the computational intelligence. So computational intelligence is that artificial intelligence where you require iterative computation or intensive computation. The artificial intelligence which is obtained through intensive computation, lot of computation you have done, and then some intelligence is obtained, then it is called the computational intelligence. Now, swarm intelligence. Of course, swarm intelligence is a kind of computational intelligence. Another category is this evolutionary computation, and another category is this artificial neural network based computation in computational intelligence. So here the swarm intelligence, evolutionary computation, and ANN. All these are the computational intelligence-based algorithms. Swarm intelligence is that computational intelligence where this iterative computation is among a group, and this computation is based on the cooperation among the group, among the group. And when instead of cooperation there is a competition, look what I said here, the cooperation, and it is the competition. This is the difference, major difference in evolutionary computation algorithm and the swarm intelligence based algorithm. So this is based on the competition. Evolutionary computation algorithms are based on the competition, and of course ANN is based on the how the human brain works. So let me start with this swarm intelligence. Of course I'll run this video also. Before that, this is the one formal definition of the swarm intelligence. Let me tell you, it is the emergent collective intelligence of the group of simple agents. Look, the very first thing is swarm intelligence is the emergent intelligence. This is emerged intelligence, not inherent intelligence. This is very important to note that it is not inherent intelligence. It is not the inherent intelligence. Inherent intelligence means it is not inbuilt intelligence. It is emerged when in a group members cooperate with each other. For example, we all are cooperating here in this workshop. You people are sharing, many speakers are coming, they are sharing some information, whichever they have. You are sharing your experiences, your knowledge with them, and we all are becoming better. We all are learning. The conferences, what is the conference? The swarm of researchers. Conference is a swarm of researchers where they are sharing the knowledge with each other. So when in a group, agents share the information with each other, then an intelligence emerges. After attending the conference, some intelligence emerges among entire group, and everybody becomes slightly intelligent. And when these agents attend one conference, second conference, third conference, many conferences, thousands of the conferences attends, then they become finally all intelligent. Many iterations. I call this just an iterations. And this intelligence is not the inherent. When they are attending the conference, when they came for the conference, the final intelligence which is emerged out of the attending the conference was not inherent. It was obtained after attending the lectures. So this is the emergent intelligence. Another thing is it is the collective intelligence. It is collective intelligence. In a group, it's an intelligence of the complete group, right? It is not the intelligence of the individual. And yeah, that's all. And of course, it is in the group. It is in the group of simple agents. In a group, always the swarm intelligence is obtained in a group. So this was the formal definition. Let me just share a few videos with you. I just made this for you. It's just a 10-12-second video. So please listen carefully. Oh, sorry. I want to name it. Yeah. So you see here. Can you see the video? Just look here. A lot of birds started flying from this tree, and then they just after a few seconds they started flying in single direction. And this is the intelligent behavior. Let me tell you, this is an intelligent behavior, and what this intelligent behavior says that they have observed that where my other friends are moving, so others are started flying in that direction. So it's a cooperative movement. They are sharing the information with each other. And how they share the information with each other? By looking at each other, right? Of course, they do not know English or Hindi, so they look at each other. And that's why, birds always rest in the night, because they cannot see. They cannot see each other. They fly in a group. Whenever they fly in a flock. So it is possible only when one can see other. And in the night, they cannot see. And that's why they rest in the night. And in the daytime, they fly. Whenever they can see each other, they fly. So information sharing. Through information sharing, they can find the most optimal direction of the flock, right? What I want to tell you, another, this video you see here, more on swarm intelligence. This let me just play this video. So you can see here. Let me just explain one by one. This is self-organized system. You can see here that the ants are carrying one, this must be a dead insect or something, whatever the object, but this object is for interest for them. They want to eat this, right? This is food for them. So they are carrying, you can see that single ant, the size and the weight of this insect, dead insect, is more than a single ant. But they are offering, all the ants are offering their services for this transportation of this dead insect. So this is the self-organized system. And you can see the left side ant, left side bottom ant, that it came here and started catching this dead insect from the left downside, so that it can help. You can see that everybody is offering its services for the benefit of the group, so that they can carry this dead insect, right? This is the cooperation. This is called the cooperation. It's a self-organized system. Self-organized system means there is no leader. Nobody is guiding them. Nobody is guiding them. Nobody is telling them that you be here, you be here, you be here, right? Everything is self-organized. Everybody has their own benefit, and based on that benefit, it is working. Because the ants know that I am the part of this colony. If this dead insect will reach at my home, or that particular place where their nest is, so if this dead insect reaches to my nest, I will also enjoy this insect. This will be food for me also. So let's work together. So this is the self-organized system. Listen carefully. I already told you that they autonomously offers its abilities. Look here, this ant, the bottom ant. Actually, I don't know if I can write this. If I can write, it will be great. No, I cannot write here. Sorry. So they autonomously offers its services. You can see the bottom left ant is started catching this insect from this side, so that it will not drop. So everybody is offering its services. So it's an autonomous system. Listen, swarm intelligence based algorithms are an autonomous algorithms, autonomous system. Look here, every ant is helping, and if it is sufficient for them, they are helping. Otherwise, they are not helping. Look here, everybody is helping them. Such algorithms could be applied to computers and robotics, and we can take some benefit of this natural intelligence to solve the problems of the human beings. We can take the help of this. And we can benefit from this from this intelligence from the nature. And you can see here that this ants and intelligence is simulated for the robots. You can see the 4 robots are there, and let's check. Let's start defining by rules. Whenever you simulate this natural phenomena to the machines, of course you need to define certain rules, that what the rules the ants are following, and the same rules we need to insert to the machines. So let's just start define by rule. So the first rule is, each ant is aware of its surroundings. Each ant is aware of its surrounding means ant understand that where I am, how many other my friends are there to help to help in this particular problem, and where my help is required, right? So each ant is aware of its surroundings and aware of its abilities. Each ant understand that what I can do, how much help I can do. Similarly, each robot must be aware of its surroundings and abilities, right? So it is full of sensors. How he can understand the surroundings? Because of the sensors, right? Because of the sensors. So you can understand that these kind of algorithms are very much helpful for self-driving cars. These days self-driving cars drone taxis, all, in smart cars, all these things are coming up. So there you can see that these kind of algorithms are very much helpful. So these robots are aware of its surroundings, and the problem is, let me tell you what is the problem. What the problem we have given to these robots is to balance this platform. To find out the optimal location where to position themselves so that this platform is balanced. So initially you can see here that it founds the position, it moves and it found the position. This is the position. So look, now the platform is balanced, but now the environment changed. I told you that they are flexible to changing of the environment. So now environment changed because of this other object, and it changes its position, right? It has changed its position, and then again it is balanced. So he has found this optimal location changed. So members are self-coordinate without a dictator. Of course, I already told you, no central control. This is an self-organized system. Members are added dynamically. Members cooperate in solidarity. They cooperate with each other, right? Yeah, this is one very important property, that when members are removed, the system is self-healing. So this self-healing is another one very good property of the swarm intelligence, that suppose 100 members are working together and 2 members die out. Suppose 50 drones are flying together, 2 drones crashed. Then the mission can be accomplished with those 48 drones also. The same job can be done with these 48 ants also. So they can change, environment change, let's do more work or less work according to the situation, right? So the self-healing capacity is there always in the swarm intelligence. So look, you can see here that now this is coordination, that both the robots are there, both have a sensor, both are aware of their environment, and they are finding the optimal location so that this platform is balanced. You can check. Now they are found, and without any dictator, without any leader. And now again the environment changed, and they again find out the optimal location of all these 3 dynamically. Members are dynamically added. They change the 4th one, and then they again, everybody is aware of their other friends, and they cooperate that, okay, you come here, I come here, and we all will balance this platform. Again, members are then self-healing. And let me tell you that this kind of system is very much important for the drone swarm. I tell you that the technology of drones is now matured, almost matured. Now the new technology is the drone swarm, not a single swarm. Group of drones are flying together, and they are doing some job. There may be one time when you will fly within the city, instead of hiring a taxi, you will hire a drone taxi. This will be reality, I think, in our lifetime. Before we die, we will see the drone taxis reality. I see that the work is very fast. The entire world is working on this problem, and very soon this will be a reality, that within city movement, we can use the drone taxis. And instead of taxi stands, there will be drone stands. And when the drone taxis will be popular, of course, there will be a traffic in the air, and at that time you will require the swarm intelligence. How the drones will cooperate with each other so that no accident, and they will find out the most optimal path without collision, and obstacle avoidance, of course. So it's okay. These are few properties which are to be inserted in the algorithm so that we can make the swarm intelligence based algorithm. The robots can, these robots are truly exhibiting the swarm intelligence. So whatever the properties I mentioned here are actually the properties which are to be inserted in that. Um, okay, let's come to these slides. Okay, so these are the properties of the swarm intelligence. Let me list them one by one. So before I list the properties of swarm intelligence, let me tell you some popular swarm intelligence based algorithms. Uh, frankly speaking, hundreds of the swarm intelligence based algorithms are available, and I cannot list all those algorithms. Of course, many algorithms I should add one more algorithm, GWO, in this category here. There are hundreds of the algorithms available. I listed few which are relatively popular, and this is not that popular, but since I'm the one part of this algorithm who developed this algorithm, so I listed it here. The most popular algorithm that I want to tell you are these two. 80% of swarm intelligence market in industry is captured by these two algorithms: particle swarm optimization and ant colony optimization algorithm. Particle swarm optimization and ant colony optimization, these are the only two algorithms which have actually inspired other hundreds of the algorithms for the development. Of course, other hundreds of the algorithms have some different properties, but they are one or other way inspired from either PSO or ACO. Let me tell you, frankly speaking, other algorithms are either inspired from PSO or ACO, some other plus other properties, but they have one or other way the concept of PSO and ACO. So, and the other algorithm is this artificial bee colony algorithm. I can say that the third important algorithm. Spider monkey optimization algorithm is proposed by our group, my research group, including me, and one researcher from France, Maurice Clark. So we 4 people developed this algorithm in 2014, and very recently this GWO algorithm has been introduced by my friend Sayyid Ali Mirzali. So this is now becoming very popular. Actually, recently this algorithm is taken over. This algorithm is has surpassed other algorithms and become very popular as compared to other algorithms these days. And it is very good for continuous optimization problem. Now, of course, I'll explain you these algorithms in detail also. In detail means not in full detail. Of course, one algorithm requires 1 day complete for detail, but I'll explain you more on these algorithms. But before that, let me come to the another category of computational intelligence that is called the evolutionary computation. Evolutionary computation is another category. Before I explain you what is the evolutionary computation and so on, you may have heard about this genetic algorithm. Genetic algorithm. So genetic algorithm is in this category. Now you can make some interest. It can make some interest to you that this category is another top category of evolution of computational intelligence. So in this category, the only thing is that there is a group of individuals. Still, there is a group of individuals, but this time they are not cooperating with each other. They are competing with each other. They are competing with each other. When we all are the research scholars or professors or teachers or students, we all attend the conferences, right, to become intelligent. We want to become intelligent, so we attend the conferences. Now, after becoming intelligent or not becoming intelligent, this way we improve ourselves, right? By attending conferences, by attending classes, by attending lectures, workshops, we make ourselves intelligent. This is the one way of becoming intelligent. Another way of becoming intelligent, let me tell you what is the another way of becoming intelligent. Just imagine that there is a position of a professor of computer science in Rajiv Gandhi Pratyogika Vishwavidyalaya, RGPV, right? There is a position of a professor in computer science for RGPV. And there are suppose 10 positions, right? Suppose 10 positions are there, and number of applicants are only 5. Number of applicants are only 5. What I said, 10 positions are there and applicants are only 5. Will those 5 candidates be in any tension before the interview? Before interview, will they have any kind of tension? They know that there are 10 positions and we are only 5. So they will say that, okay, no problem. Whatever they know, they will not prepare. They will not make themselves better. They will not make themselves better. They will just sit idle. जिसको लेना है ले लेगा, मुझे क्या, मुझे तो होना ही है, right? So they will not make themselves better. But now the another situation. There are 5 positions and 50 applications. Only 5 positions and 50 applicants are there. Then what the applicants will do? They will keep on studying. They will keep on making themselves better. This way, that way, anyhow, they will make themselves better so that they can compete with other 50. So that they can compete with other members of the group. Try to understand, if there is a competition, also the people become intelligent because of competition. Also the individuals become intelligent because of competitions also. And therefore the algorithms which are inspired by this competition among the individuals in a group are the evolutionary competition. Why we call them evolutionary? Because of this competition, a new kind of intelligence evolve in that group, and that's why we call it evolutionary. And of course, it is based, all the evolutionary computations are based on the Darwinism principle of the survival of the fittest, how we, the human beings, are evolving. We, the human beings, every generation is becoming better and better. The number of hours when I was studying in school or in college, the number of hours which I study, my children are studying more than that. I secured some marks. These days, those marks are considered as the fail marks. And the percentage which I secured in my UG, PG or school level, I topped. The school, college, I topped. I got gold medal for that percent. And in this moment, if that same percentage comes, people will say that you are a very poor student. Just try to understand, the new generation is becoming better. This doesn't mean that the teachers are giving more marks, or actually students are studying more. The competition is more. Now more and more students are coming to study, coming to academics. They are studying. The number of applicants have every day are increasing. When I took my admission for PG, the number of applications were equal to the number of seats. There was no competition. Anybody who filled the application got the admission in the college. But now the situation is different. More applications are coming, seats are less. Not everybody is getting the admission in PG, PhD or UG. And they are becoming intelligent because of that competition. They are studying hard, they are working more hard, they are getting more marks, 95%, 97%. In Delhi, there is a college where the 99%, 100% marks are coming up. Of course, there is some problem with that marking system also, but not that much. I topped at 78% or 82% or something. In UG, I topped at 79%. And now in the topper marks must be 98%, 99% kind of marks. If it is not 99 exactly, it must be 95. But whatever you do, but they are 95 at least. The students are really, really very intelligent these days. So the population is evolving. Why the population is evolving? Why the members are becoming intelligent? Because of the competition. At that time also, at my time also, I may have obtained 95% if I feel that I will not get admission or I will not pass if I will study this much only, right? So because of the competition, also the members become intelligent, and this intelligence is called the intelligence based on the evolutionary computation. And there are many algorithms in this category, and how this evolution works based on this reproduction, mutation, recombination, natural selection. Of course, I'll tell you one by one on this. What all this is, let me tell you. Before that, let me tell you, the popular algorithms in this category is this genetic algorithms. Everybody heard of this genetic algorithms, at least name everybody heard. I'll tell you some details of this also. genetic programming, evolutionary strategy, cultural algorithm. These are the differential evolution is one of my favorite algorithm in this category. However, this differential evolution is not purely evolutionary computation based algorithm. It has some exceptions than the evolutionary computation. The differential evolution has some exceptions. For example, in evolutionary computation, what happens? The crossover is the first operation and then the mutation. Means the mutation is of the after the crossover always. But in the differential evolution, the mutated population takes part in the crossover. This is the one basic difference. Also, the mutation is based on the differentials of the individuals. That's why it is called differential evolution. Of course, evolutionary operators are there, crossover is there, mutation is there, evolutionary algorithm is there, but it is based on some differentials of the individuals, right? So it is different from the genetic algorithms, entirely different concept. One of my most favorite algorithm, very fast algorithm for continuous optimization problems, very fast and very good algorithm. Biogeography based optimization is one very recently introduced algorithm based on the migration of species from one island to another island. Why do the people migrate from one island to another island? I belong to Gwalior, right? I studied in Gwalior. I got a job also in Gwalior, but then I got better job in Delhi, so I migrated. So this is one reason. No? So I made myself better by migrating. If I'll be in Gwalior, I will settle with that job. If I get better job, I migrated. So I made myself better. So how based on the migration also, the islands become better or worse, right? So based on this algorithm is developed. One US scientist, Dan Simon, in 2008 developed this algorithm. This is also very good algorithm. So now let me tell you about, just in short, I will explain each of these algorithms in short. Professor Sikha, I think I can speak till 1:30.
Yes, sir.
Okay. So just quickly, let me tell you on means some introduction of these algorithms quickly. So with this single slide, I can explain you the spider monkey optimization algorithm. Of course, I will not explain you the equations here, but I assure you that if you will listen carefully of this explanation, then you will be able to understand the entire algorithm, right? So just for your information, in 2014, we developed this algorithm, myself, my two PhD candidates, two PhD students, the then PhD student, now they are the professors actually, Dr. Harish Sharma and Dr. Simpi Singh Jadon, and the one Maurice Clark from the France, who has pioneer work in the particle swarm optimization. Maurice Clark is the top name in particle swarm optimization. He has written a book also on particle swarm optimization, very famous book on particle swarm optimization. Also a book on complexity theory. So we four people introduced this algorithm in 2014 when I was in Gwalior, Triple ITM Gwalior, ABV Triple ITM Gwalior. At that time, this algorithm was published. So how this algorithm works, let me tell you. Actually, what happens, it is inspired by the foraging behavior of monkeys, and very special kind of monkeys, foraging behavior of spider monkeys. First of all, let me tell you, there is nothing but the spider. Spider monkey is a special species of monkeys which live in the deep forest. They live in the 50 to 60 individuals, means 50 to 60 monkeys live together. They live on a single tree habitat, right? And they live like a colony, and they cooperate with each other. They cooperate with each other in search for the food. Foraging is food search. So they search food together, and when they live together, a special kind of intelligence emerges among them, and that intelligence is used to develop an algorithm that is called spider monkey optimization algorithm, SMO. So what happens here, there is a group of monkeys, they identify themselves a leader, right? Now you immediately can ask me a question that you said that the basic property of swarm intelligence, that it is a self-organized system, no dictator, no leader, no central control, right? But you have defined a leader here. So let me tell you, this leader is not that kind of leader. It is simply the leader who is the best solution, who has the best information available right now. So suppose there are n solutions, whichever solution has the best information available, means the fitness of the solution, whoever has the best fitness will become the leader, right? It is not index based leadership, it is the performance based leadership. It is not the, that somebody took birth in a family and become the president of a party, right? So it is not just based on the birth, that if you have this surname you will become, by default you are this, right? You are a king. It is not based on that. It is performance based. When it is based on the index based leadership, that X1 is always the leader, then it is a leadership, then it is a dictator. No matter X1 is a good or bad, but it's always a leader. Then it is a index based leadership, surname based leadership. So no surname based leadership, right? It is based on the performance. Whoever will perform better will become the president or will become the leader, right? So this leadership is that kind, and it's a dynamic leadership. It is not fixed leadership, right? So I hope now you can understand that it's not a central control. So still we are following the swarm intelligence properties. No swarm intelligence properties are violated in this algorithm. All are followed perfectly. Okay. So what they do, when the group of monkeys search for food, they find the food source. Suppose they find the food source and they start eating. They start eating. After eating this, after some time, if they realize that there is not sufficient food in this area, then they divide themselves into two smaller groups. Instead of one single group, they divide themselves into two smaller groups. Suppose 60 individuals started here and they find the scarcity of food here, then they divide themselves into 30 groups. 30 groups, they divide themselves. And this process is called the fission. This process is called the fission. I think this word meaning understand. So fission, they divide themselves into smaller groups, right? So this is called the fission. Now again, this 30 members group started food foraging in different direction. It started in different directions. Now when he started in different directions, suppose this group finds this food source, and when he finds this food source, this group finds food source, and if again this group realized that the food is not sufficient, then it will further divide itself into smaller groups, right? Smaller groups. So suppose these two groups are formed by this, and these two groups are formed by this. Now the groups may be 4, 68, 16, and so on. So this process continues. The fission process continues until maximum number of groups are formed. Until maximum number of groups are formed, or the evening. In the natural phenomena, what happens? The monkeys keep on dividing themselves into smaller groups until evening, right? And in the evening, when the sun set, they return they return to the habitat wherever they live. They return here, and when they return here, when they return at the home, this process is called the fusion. Means this make a single group. Throughout the day, they are making fission, and at the evening, they are making a fusion, single group, fusion, and they come here. And after coming here, every smaller group will have the leaders. These smaller groups will also have the leaders. And now, since there are two groups, not a single group, there are two leaders. So this time we call them the local leaders. We call them the local leaders. And this time, this leader is called the global leader. We call that the global leader, right? So now there are two types of leader, global leader and local leaders. The best in a single group, overall best, is the global leader. So when they return at the habitat in the evening, so in the night after after having good lunch and dinner, they talk each other, they chit chat each other, and every leader shares the information with each other, sharing of the information. And what is the sharing of the information? One leader says that I went in this direction of the forest and I found this food source, and this much amount is there. This is the food source, and how far it is, in this direction it is, and this is very close, no competition, no other group is there, and so on. Many things they share with each other. So then other leader also says, now the global leader is there, or they share the information with each other. Out of them, they find out that, okay, your information is better, your food source is better than my. He says that, okay, his is better. So out of these all informations, one information must be the best information, the best available food source. So next morning that monkey will become the global leader, and he will guide to reach at that particular food location. So they start from that particular location. What is the benefit of having this fission and then fusion? This is called the fission fusion social structure. What is the benefit of having this fission fusion social structure? That if they would have surged in a single group, then they can explore a limited area of the forest. But when they have done this fission according to the requirement, then first of all they avoided the competition. Just imagine, if the food is less, requirement is more, there will be competition. But when in the US, when you drive and on the circle or some cross section, you will see that you are driving, you are coming. And in India, what happens in Delhi, what we do, पहले मैं जाऊंगा सबसे पहले, अब गाड़ी आगे से निकाल के ऐसे लेके जाते हैं. When I first shifted to Delhi, एक हफ्ते तक तो मैं चला नहीं पाया था गाड़ी. I just and in the US, what happens? Actually, the crowd is not there, and that is why those people are so sober. And they always say that anybody who sees first will stop its car and say that you go, right? I just amazed to see that. What is this in Delhi? What we do, even if the one is moving, we take some dangerous turns and take the car ahead of that car, because here we know the competition is there. If we will give the path to others, then we will never reach to office or never reach to home, right? The infinite number of passers are there. But in the US, he know that after 30 minutes, another car will come. Enough time is there. Competition. To avoid the competition, they have made the fission. To avoid the competition. Otherwise, there will be a competition. So to maintain the cooperation, they made the fission. And because of this fission, they have explored more area of the forest, and the better regions of the forest are explored. Means the search space can be better explored in this way. The optimal solution can reach relatively in better way, right? So means the chances of reaching at this optimal solution increases when they are searching in smaller groups in different regions, right? Instead of in a single group. Let me tell you that how we have this. I already told you that evening age means maximum number of groups are formed, and fission. So the fusion is based on the there are two things, fission and fusion. Right, so fusion is based on the maximum number of groups are formed, and fission is based on what? When they will divide themselves in the natural phenomena, when the scarcity of food. So in our case, we have defined it with the no improvement in the solution, in the global leader or the leader, right? If the leader is not updated, if the best solution is not updated, means best solution is not updated means if X1 is the best solution, and in next iteration, if you are not getting any other solution which is better than X1, then we say that solution is not improved. Whatever the best solution available, it remains same. X1 is the same solution, right? If the solution is not improved, if the optimal solution is not improved, then we call it's a time for the fission, right? This is the way how we define the conditions for this fission and fusion. Let me tell you, all this is based on some probability. All the fission, fusion, update, all this is based on certain probabilities, probability of perturbation. We defined. You can go ahead with the website smo.scrs.in. So from this website, you can download the codes of this algorithm. You can download the original paper also. And of course, nowadays, the Google Scholar is there. You just search and you will find all the other resources related to the algorithm, right? Particle swarm optimization is another algorithm which is inspired by the birds flocking behavior or fish schooling behavior. How the group of birds fly together, how the school of fish swim together, and why they swim together, why they fly together. It is smo.scrs.in. I hope it's okay. Somebody wrote in the chat that website again. So okay. So the fish schooling or birds flocking. So the rule is very simple. How they fly together, right? The rule is very simple. First of all, the one member is getting the experience of getting benefit of the experience of other. That's why they are together. If they will fly individually, if they will fly alone, they have to explore all the directions. Only then they can find out the optimal direction. But now, this bird has, suppose this is the bird, one bird is here, one bird is here, one bird is here, one bird is here. This bird has searched this direction, this bird has searched this direction, it has seen this direction, and this bird has seen this direction, and this bird has seen that, okay, this direction is the better direction. They share the information in real time with each other, and they share the information that, okay, this is the correct direction. This bird has not seen these two directions. Still, the entire group is moving in this direction. And in fact, these other birds has not seen any direction. Still, they are following this, right? But of course, the honesty is there. Honesty is there, that no misguidance. But even after having the honesty, misguidance may be there. Let me tell you why. How the misguidance can occur. Actually, what can happen that this, let me quickly tell you, this fish is swimming in this direction. It sees some danger here, so it started moving in this direction. But it has not taken, at that particular moment, it may not have taken the information from this, that even the bigger danger is in this direction. So some misguidance may be there. If without looking own experience of by this member, this fish started following this and he also started in this, then the entire group will move in this direction and they will be trapped in this big trouble, right? Therefore, the two type of learning is there in the PSO. In PSO, we apply the two types of learning. One is the social learning, means whatever we learn from others, from this, and one is the cognitive learning, whatever is own our experience. So we don't leave in PSO, we don't leave our own experience. They maintain our own experience also, that you look, where are you moving? Can you see some danger? If you see the danger by yourself, don't move in that direction, even if that is guiding you, right? So another is this artificial bee colony algorithm. Let me just show you one video on this, and then I can explain you better. Just hold on. First of all, let me tell you that this algorithm is inspired by the foraging behavior of honeybees. How the honeybees forage, right? Forage, search for food. So let me tell you, honeybees live in a hive. They are three types of honeybees are there: onlooker bees, employed bees, and the scout bees. Onlooker bees are always on the hive. Employed bees always extract the nectar from the flowers. Now, what happens when these employed bees extract the nectar? They return to the hive, right? They return to the hive, and then the onlooker bees, who are already on the hive, they recruit for extracting the nectar. So they do this job alternatively. That some bees rest at the hive, then extract the nectar, then they return, then they go, right? This way they are cooperating with each other. Now, in this cooperation, what is having, that when this employed bee is returning with the nectar to the hive, this onlooker bee doesn't leave blindly. It takes the information from this bee who is returning bee, from where you are coming, is the sufficient food there, which flower it is there, is it good to go in that direction, and if it is, which direction it is, so this onlooker bee who was resting on the hive, it is taking benefit of this discovery by this bee who is returning bee. So, and this sharing of the knowledge is done with the different type of dances. One is the waggle dance, and out of 3 kind of dances, tremble dance, round dance, and waggle dance. Out of these 3 dances, the waggle dance is the one most important, and it is this, the bees do the dance. Of course, they do not know English. They have not attended the school, so they don't know the English to share the information. For example, I know English, you know the English, Hindi, so we can share the information with the languages. So they have the language, their own language, and that is the dance. Every living being has their own language of communication. Don't see that the animals do not have the language. They all have the languages. We have the languages, right? We are better than the animals who cannot speak because of this, that we have a language, fully developed language. We can write even without speaking. We can share our views, right? We can read the books. So they can survive based on the dance language only. Just waggle dance is sufficient for survival. Sufficient. So how they do this? It is a real video. I took it from YouTube. Please let me tell you that credit is YouTube video, so it's not my. So don't know why it is not.
The scout.
Can you
Performs a so-called
listen?
Sir, mic is moved.
Oh, sorry.
Coming.
Sun. Yes. It happens when the 2 systems are at the same place. So I hope now you can hear me. Umesh Geraji, you please mute yourself. You are iteratively, unmute, and then there is a sound. So it is making the dance. This bee is doing the dance here, and this dance is in particular direction, and this direction is based on the reference point of the sun. When this bee was on that flower, the flower and the sun was making a certain angle, so that same angle she was making while the dancing. So it is informing other bees that the flower is in this direction. Now she will do the dance with certain intensity, very fast. Then it says that okay, good amount of if it is very fast, it means it is closer, it is not too far. If the duration of the dance is more, then it means it has more nectar. And which flower it is, then other bees touch this bee, touch its antenna. So when she was collecting the nectar, the smell is there, so they can touch the antenna and can smell that okay, from this particular flower she is coming, and the rose flower is my favorite, so I will go to this flower. So onlooker bee decides their recruitment based on this dance, right? And they can minimize their search. Otherwise this bee has already searched, she has gone in this direction, and then she found that particular flower. But now the onlooker bee has taken the advantage of its discovery. But now the onlooker bee has taken the advantage of this. I hope I'm clear on this. Clear? Okay. So this this algorithm is implemented in three. This algorithm is implemented in three phases based on the number type of bees. Employed bee phase means how the employed bee works, and then onlooker bee phase, and then the scout bee phase. Okay, so another algorithm, the ant colony optimization algorithm, which is I always tell that very famous algorithm, and of course very good algorithm also. It is inspired by the foraging behavior of ants. It is inspired by the foraging behavior of ants. Ants foraging behavior. How the ants forage, and how the ants always find the shortest path from one point to another point. Just imagine this is the destination or the food. Suppose this is your food location and this is its nest, and there are suppose 4 paths available. You can see that this path A, B, C, D. Out of these 4 paths, this A path is the shortest path. I want to tell you that ants will always follow this path. They will not follow these 3 paths, right? How they always follow this shortest path? How they find? If somebody will tell me that what is the shortest path from Delhi to Bhopal, I have to see the Google map. And how the Google map is answering me? He has a satellite. From satellite, he know that, or based on the previous mapping. The Google map is giving me the shortest path from one point to another point. Now ants have not launched the satellites. Ants have no satellites. Still they find the shortest path. Can we take advantage of this this intelligent behavior for our robotic path planning problem, where there is no GPS system? Without GPS system, without maps, without Google Maps, they find the shortest path. Can we take the advantage of this in GPS denied environment? In GPS denied environment, can our robotic system, group of robots, can take benefit of this and can move from one point to another point in the shortest possible path? Yes, it is possible. And let me tell you, this ant colony optimization algorithm is one of the best algorithms for the robotic path planning problem. And how it works, very simple rule. When the ants start, they put some pheromone on the path. Initially, all the paths are followed randomly, right? And they put the pheromone, and this pheromone evaporates with time. So the larger paths will have more evaporation and shorter path will have less evaporation. The first rule, put the pheromone. Wherever you are going, just put the pheromone. Second rule is follow the high concentration of pheromone. When the next ant will move, it will see that this particular path has more pheromone as compared to these 3. So more and more ants will keep on moving on this path because it is shorter path, right? So more and more ants will keep on moving on this path, and ultimately all the paths, after few iterations, all the ants will keep on moving only on this path, and no ant will be on these paths. So after few iterations, this path will be the shortest path. And this problem is very good in traveling salesman problem, scheduling problem, robotic path planning problem. Very good algorithm. Timetable problem. Biogeography based optimization is actually I have only 10 minutes now, so just quickly I tell you that these are the islands, suppose means the solutions, and these are the independent variables. And what happens, how the individuals become better? This is suppose any other individual. So it will take some information from this, one variable from this, and ultimately it is considered that the good variables are taken from this. This is the good property of this habitat. This is the good property of this habitat. This is the good property of this habitat, and so on. So they are taken into this habitat, and ultimately this will be the best habitat. Genetic algorithm is inspired by the survival of the fittest. How it works? First of all, the selection is done. Means who will take part in the crossover? You know, everybody. It is simple in like how we we see in our human beings. You know, mother, father. You know, they are selected that this will be the mother, this will be the father. Then they generate two offsprings, children, child one and child two, right? So this is called the crossover, right? This process is called the crossover. Selection means who will be the mother, who will be the father, who will take part in the crossover. You know, everybody is not authorized or is not has the rights to produce the offsprings. Only the good people. You know, हर एक की शादी थोड़ी होती है. Those who can earn the money, who can feed the children, only that boy will get married, or the girl, right? So this selection is based on the fitness, and after that they will produce children, and out of these four, now there is a competition that who will survive, right? Based on the evolutionary, whoever out of these four, whoever the two best will survive. So maybe one mother and one child, one father, one child, both mother and father, whoever is the two best will survive, right? Will be here. And then they take part in the mutation. Mutation means a small change in that, right? And then elitism, this is an optional operator. What happens, you know, there are certain individuals which are the top individuals, and it is not expected that they will become better by taking part in the crossover and mutation. So we keep them as it is, just to for the high convergence rate, to fasten the algorithm, to make the algorithm faster, right? Okay, and then I just want to share a few things about the success stories, successful applications of these computational intelligence based algorithm. This is the one published paper in 2018 in Science Robotics. Very good journal, very good paper. The paper is a complete paper to understand the drone swarm. Let me show you one video on this. I took one video also. It is the you see here that this is the group of drones which are flying together in autonomous way. You can see there, they are now, you know, the birds, like they are flying like birds. And let me tell you that nobody is controlling them. It's an autonomous system, fully autonomous. They are making consensus with each other and flying, and they accomplish some task also. I don't know whether this demonstration is there in that YouTube link or not, because still I just came to Delhi from that demonstration, so I have not seen that it is recorded in that demonstration or not. But just yesterday we also did this with 9 drones, and mission accomplishment was done very nicely. In just 7 minutes we completed the mission. Okay, so this is the one successful application of swarm intelligence based algorithms. Another is this evolutionary computation. Let me tell you, genetic algorithms application is this aerodynamic design of this bullet train, Japan's bullet train, Shinkansen N700. This is the best available design till now, which is obtained by genetic algorithm, right? Similarly, you can find out the best aerodynamic design of cars. You know, new cars are coming, so aerodynamic design of racing cars, passenger cars, trucks, bus, wind turbines blade. You know, wind turbines blade is also should be very aerodynamic, so that with the minimum wind they can fly, they can rotate. This is another problem related to wind turbine, to find the optimal location of wind turbines, so that the effect that is called the wake effect, actually a wave effect of one turbine to another turbine is minimum. And I solved this problem using BBO. We published 2 research papers also on this. So what I want to tell you that there are many applications of these algorithms. The major work that you can do with this, try to understand any one algorithm, take any one algorithm, and one algorithm is sufficient. try to understand that completely, code it, run it, and then think that can I modify this algorithm, solve your problem. If you have a problem, model it as an optimization problem. Model it as an optimization problem, as an optimization problem model, right? And then solve this. Then you can compare this with other algorithms, or you can do that. So what's next? What I say that right now, having the more computational devices, these days the supercomputer efficiency is increasing. Even your laptop is giving good efficiency in very cheap rates. Very high computational devices are available. So because of that high computational devices, the best AI nowadays is the CI, computational intelligence. And from the application point of view, whether it is a self-driving cars, smart cars, drone taxis, drone swarm, or robotic swarms, or the application in biomedical sciences, if you ask me, the best CI is swarm intelligence. So I say that if you are interested in AI, please explore CI. If you are interested in CI, please explore SI also, right? With this, I complete my talk. Thank you so much. I'm okay to take the questions now. Thank you so much. So I just deliberately leave 5 minutes just for the question answer. If you have, please tell about ABO, African buffalo optimization. Yeah, I heard about this algorithm, Saranya D. But frankly, I have not read this algorithm. Every day a new swarm intelligence based algorithm is coming. So of course we cannot. But I heard about this algorithm. I see the paper, but I have not read that. So I cannot tell you. But let me tell you, it's all one way or other way. If you can understand this PSO, I promise you, if you understand PSO, you have understood all these algorithms. No matter it is ABC, it is African buffalo optimization, it is GW or some other algorithm, you will understand all other algorithms if you understood properly this PSO, right? As you said, if I have to learn AI, do I have to first learn and explore CI? No. Not first CI and SI. These are the parts of AI. So in AI, I say that CI is a good candidate for the new technology. So please explore CI also. AI is there. Many technologies are there where yes, I will share the PPTs with the coordinator, with the Professor Sikha. I'll share the PPT so you can take from her. Okay. Share PPT and notes. Yeah, you can. Otherwise, you can just let me type in the chat. Okay, here. This is my. You can just. This is my web page. people.sau.in/jc1sal. Right. So you can just go here and click here on the resources. Video lectures are there and lecture notes are there. So many video lectures are here. If you want to learn ant colony optimization, I promise this is a very good lecture. Very simple. Differential evolution, spider monkey optimization, it is 3 parts. Biogeography based optimization. Many other lectures are there, but I have not uploaded, but these lectures are still there. So you can just explore these, and I think some notes are also there, some PPTs. Yeah, here are the lecture notes, and this is okay. These are also some video lectures, some performance indicators. When you will learn all these algorithms, when you will write research paper, then you will require these resources. Let me tell you, then at that time you will require these resources, these video lectures, right? So you can just explore this. So in fact, at that time, now you no need to share these slides also. Okay, so Not here. So, okay. Let me stop this sharing and then. Now, any other question? If not, then we can. Okay, thank you so much for patience listening and for your attention. Thank you so much. I'll be happy to have any question. If you have any question or if I can do something for your exploration this area, you drop an email to me. It is simple. My email is very simple, jcbansal@gmail.com. I'll try my best to help you out if you want to explore this area. Thank you so much. Thank you so much. Madhuri Agrawal.
Yes, sir.
Yeah. You are taking care of the session.
Oh, ji, sir. Yes, sir.
I think I cannot see the Professor Sekha here, so I think.
Yes, sir. Sir, thank you so much. Just I want to give you the thanks. On behalf of RGPV, I extend a really hearty vote of thanks to our expert, sir, Dr. Bansal, sir, who spared time for his busiest schedule to grace the occasion. Today, we had an opportunity to hear your thoughts on swarm intelligence. This will surely be going to encourage us in our future events. Thank you so much, sir. Thank you so much, sir.
Thank you so much. Thank you, everybody. Thank you.
Thank you, sir. Thank you. Thank you so much, sir.
Oh, Agrawal sir. Hello. Who's there? Professor Jitendra Agrawal?
No, sir. No, sir. I'm Praveen Kathal. I'm on behalf of Shikha ma'am right now.
Oh, okay. Thank you. Thank you so much.
Thank you, sir.
See you.
Thank you.